In the interest of keeping things consistent, I'm going to do question D before I do question C, because C is a little bit different. We'll deal with that difference later. D, just to relate the question out again, 4 root 11 over y root 6. I'm not going to relate the condition, doesn't matter to us. Fact is, we still have a root in the bottom. Fact is, we need to eliminate it by multiplying top and bottom by root 6. And this does not want to take my input today, so we'll try, there we go. Try that again. So on the top, we have the 4 root 11 times 6 is 66. On the bottom, we have the y, and under the root, 6 times 6 is 36. Look to break down. On the top, square root of 66, we can divide it by 2, we're at 33. Divide it by 3, we're at 11, and 11 is prime. On the bottom, we have the y. Square root of 36, divided by 2, we're at 18. Divided by 2 again, we're at 9. Divide by 3, we're at 3, which is where we need to go. Looking for groups, none on top, but we have a group of 2's and a group of 3's on the bottom. We can multiply the top back together and go back to 4 root 66. I apologize, this is not working how it should right now. 4 root 66. On the bottom, the 2 and the 3 come out, multiply into the y. We have 6y. Look to cancel the 4 with the 6y. 4 and 6 reduced to 2 and 3. And our final answer would be 2 root 66 over 3y. Stepping back now to question C, we have 11 over root 5 plus 7. And again, ignoring the condition here. What makes this question different from the rest is that we have 2 terms on the bottom, one of which is a root and one of which is not. 5 is a root, 7 is not. That complicates things because we cannot just multiply by root 5, because that will just shift the root from the 5 to the 7. What we need to do is multiply by something called the conjugate of this expression. The conjugate has the exact same terms, so root 5 and 7, but instead of a plus sign, it has the opposite sign. It has a minus sign. We'll do that top and bottom. So whenever we have 2 terms on the bottom, we need to multiply by the conjugate, and the conjugate just has the opposite sign but the same terms. So to multiply out the top, this 11 needs to multiply into both the root 5 and the 7. So 11 times root 5 is 11 root 5. And 11 times 7 will give us minus 77. On the bottom, we have to FOIL, so root 5 times root 5 times negative 7, 7 times root 5, and 7 times negative 7. Gets a little bit longer. Root 5 times root 5 would give us root 25. The outsides, root 5 times negative 7, would give us negative 7 root 5. The inside, 7 times root 5, would give us plus 7 root 5. And the last, 7 times negative 7 will give us negative 49. And again, if you're looking at this and looking at the bottom, you'll say, well, hey, we didn't eliminate the roots. Instead of 1, now we have 2, actually 3. But if we look at those two in the middle, negative 7 root 5 plus 7 root 5, they cancel each other out. And that's the design of multiplying by the conjugate. It will cause that to happen naturally. Okay, so we've eliminated 2 out of the 3. Well, give me 1 minute and we'll eliminate the last one. We have on top 11 root 5 minus 77. We can't do anything about that. They're not like terms. On the bottom, hey, we have that square root of 25. But the square root of 25 is actually 5. And this is the second half of the design of the conjugate. It will make that root that's left over a perfect square, and we can actually take the square root of 25. Be done with that. We've canceled the 2 middle terms. We have 5 minus 49. One last little bit of simplifying to do. Again, the top we cannot deal with. The bottom, however, 5 minus 49, simple subtraction, negative 44.